In Math 30-2s, here we're going to do equations and sinusoidal functions. If I give you the equation, can you analyze them? So these are more real-world examples, and then we'll do some regressions. So you can see that I already have my Desmos here loaded up. So even before I start the question, I'm just going to type this in here. You're probably going to need this equation, so I'm going to type in 59 sine bracket 0.5. Instead of m, I'll have to use an x. As soon as I do that, I made a line there, bracket plus 136. Okay, now because of that 136, that's my remember that's my midline. My graph is going to be way up here, so I'm just going to hold down Shift, change that. I didn't want to change too much of this because the graph looks pretty good that way actually. So that looks nice, looks pretty good. So what is the average monthly heating bill according to this model? Well, you could think about the average being the middle of this line here, is the medium, halfway between the max and the min, which is also just the midline. So this is just going to be the midline. So I'll write that in here. So this will just be the midline of 136. And F represents the amount in dollars, so it's $136. What's the highest bill would expect to receive here? So I go to my graph, and I can pick one of these max points. They're all the same, but it looks like you get a max from the graph, 195. But you can also do it from the equation too. We could say, okay, that's my midline plus my amplitude. Mid plus my amplitude. And I get that 195 as well. How much should a family expect to pay in May? Assuming January is the first month. So January, February, March, April, May. So the 5th month. So let's pull out the 5th month over here. So I just drag my mouse over around $100 actually. $99.9. 99.9. Now remember, you could just drag your mouse across the graph, right, to find any point, but you could also just type in, let's move my talking head out, that's fine. You could say X being the month, right, because M is X now. Say X equal to 5, and then there's a nice vertical line there for us. I know what that is. And I could actually move that around if I want, wherever I want. I'm just going to type that 5. Okay. During which month is the heating cost the lowest? Okay, so I go back here, hit this, and you can see here it's 6.8 months. So which month is that? 6.8. So that's in the, what is it? January, February, March, April, May, June. In the month of June. It's getting close to July, but that number is in the June, so it's not quite the 7th month yet. So I'm going to say June, 6th month. Okay, there we go, not too bad. This one here wants to do regression, so it looks like we're going to do a regression, or sinusoidal regression, so that means I'm going to pull up my regression sheet there, so I'm just going to close this one down, and then pull up my other sheet that I have here. Remember, you can find this link to the regression, the Desmos regression, on the Google Classroom there. So I'm just going to type this in. So we got months at the top there. So I'm going to have to just put in months as numbers. 1 for January, 2, 3, 4, 5, 6, 7, 8, 9. I've lost it. So I'm just going to move this over here. And one more. 12. And then I'm going to put in my other numbers, 4.4, 3.2, 3. So you can see there's a graph forming there already. Ooh, by doing that, this kind of really messed everything up there. 0.2, 0.1. Okay, now we're back to a regular regression, looking pretty good. 0.2, 1.2, 2.9, and 3.1. Okay. So let's zoom into our data. Hold down Shift, you can just move that around. Pretty good. There's about one period there from a crest to a crest. Looking nice. I'm just going to head down here. So looking at this, what's the period of this graph? Okay, so first of all, I'm going to write down what my regression is. So it's A sine. So A, let's put 2 sigdigs here, or 2 decimal places, sorry. So this is going to be 50 sine, because it's 497. So that 7 is going to round up the 9 to a 10, which will round up to the 5 as well, or the 4 to a 5. My B value, so this is BX, 0.41. Now let's go 41, okay. Plus my C value, 1.78, bracket, plus my D value. Everything's positive here, so that's really nice. Cool. So there is my equation. What is the period of this graph? Okay, so just making sure that this was in radians to start off with. Yeah, my radians. So to find the period of this graph, you can try to read it off the graph here too if you wanted to. You can go my max to my max, take those 2 max values and find the difference between them. But we could do this using the equation as well. So my period is going to be 2 pi divided by my B value. There's my B value there, so I'm just going to type that in my calculator. 2 pi divided by 0.41. Now you want to use more decimal places. I could use more decimal places because I could see my equation there. So I get 15-ish. 15 months. Cool. If I look over here, I could do the same thing. I could subtract those 2 numbers. Now you have to watch out when you do that, you subtract a negative, so you're technically kind of adding them together, but you do get about 15 months there too. What's the range of this function? So the range is my y values. So you could use y, you could use precipitation, so you could use like a p here. I'm just going to use y. They don't specify the variable. Now I want to go from the lowest point of the graph, not the lowest point on the precipitation, but on the graph here. So the lowest point of the graph is negative 0.2. Doesn't really make too much sense to have a negative precipitation. Oh yeah, it doesn't make sense at all, so I'm just not going to bother with that. So 0 is the lowest of my graph. Yeah, it just makes sense. Wouldn't have that. And my max here, I have it highlighted already, so it's 4.75. Well, here. Oh, caught myself. I was going to put down a negative number there. That wouldn't make sense. How much does the precipitation vary in this period? It varies. Maybe from the max to the min, so I'm just going to subtract them. So it doesn't specify, are these like millimeters or something? I don't know. 4.75 minus 0, but 4.75. What's the minimum point? And what does this mean in the context of the minimum point? Like we decided already. The minimum point is 0.244, but this doesn't make any sense. Since I know my writing's been horrible lately. Precipitation cannot be negative. So actually the minimum point should be 0, right? That's why. So I'm just going to mention that. We're going to put a little arrow here. Okay. Which parameter of the regression should be used to determine the average amount of precipitation? So based on the regression, what is the yearly average? Okay, so I would have to use the midline, right? So average is right in the middle there, halfway between the max and the min. I'm going to have to say midline. I'm going to put that halfway between max and min. Okay. Based on the regression, what do we know? The midline is 2.25. Oh, it's in inches. Okay, that's good. I'm going to have to put that in inches. Sorry. It does say inches in the question, so I'm just going to write down some units here. Inches, months. Yep, there we go. looking pretty good. So here's another question regarding regression. I'm just going to delete a bunch of things. Type this in here. So we got 1984. 1985. Okay, good. 6, 7, 8, 9, 90, 91, 92, 93, 94, 95. Decimals being nice to us. Okay. 8.539, 8.312, 8.237. Okay, it's forming some kind of graph over there. You can kind of see it. 7.425. Oh, I kind of lost it there. Hopefully it comes back to us. Oh, here's that. Oh, it popped up there for a second. Now it's gone again. 6.528. 7. 8.628. 9.613. Oh, look at the data points. I'm looking at the R squared here. It's not very nice, R squared. Where am I right now? Okay, I'm 8.940, 7.996, oops, and 7.44. There we go. Okay, so if I want to find the data points, my X values are huge here, so I'm going to have to, or I'm going to go over to, there's my data points there. So I'm going to stretch them back out now. Trying to, remember, you could always go to the window and just play around with the window too. Actually, not a very good R squared, but we're going to assume that that's what this is supposed to be. Enter the regression. When entering, use the following. 1, or you could do that too. 1 to this. It says, I could fix it up by doing that as well. I'm just going to leave it here. This is fine. What is the period of this function? So from max to crest, you could do it that way. So I can subtract these two X values here. I can do that. I can use the regression formula because I know what the B value is. So there's a few different ways to do this. I'm going to go 2 pi divided by my B value for this one. So 2 pi divided by my B value, 0.804873. Okay, so 7.8. I think this is in years, yeah. Cool. Was there a horizontal phase shift? Was there a horizontal phase shift? I think there was. Now to determine if there's a horizontal phase shift, if I put these back the way they want them, just let me do that just 1 second. Okay, so I retyped in the data using this information from 1 to 3, 4, 5, 6, 7, 8, 9, 12, assuming 1984 is 1. There's 12 data points here. Now, determine if there's a phase shift. You have to determine, does the graph, the y-intercept, the y-axis, sorry, does the y-axis, the midline, and where the graph is going upwards, do they all intersect in the same spot? So I'm going to add in the midline. I'm going to use the data here. So D value is 7.77142. So if you look at that, you can look at that and say, oh, they don't quite all match up here. So there is being a phase shift. Okay. Another way to determine if the phase shift there, if there is a C value here. So a horizontal phase shift, yes. By, and I'm going to go a C divided by my B value. So I have my numbers here. So my C, 0.95292. Now, if you use your TI calculator, you're going to get a different number than this one. That's fine. There's lots of different answers for phase shifts here, but in this case, the phase shift they're using here is 0.37. I'm just going to go with 7. Right? That's the phase shift. Right? How do we know? We just know that all 3 of these points don't match. They don't line up. I don't know what I'm spelling there. Here you go. What's the average number? of the unemployed people what is the average number of unemployed people and what part of the model did you use to finding? And so this here, the average number from halfway between min and the max is going to be my midline again. So my midline is 7.77. Now it wouldn't make sense. It's going to be percentage, right? Assuming in millions, 7.77 million people. That's a lot. Is this in the US or something? Yeah, okay, cool. What's the range of this? So I'm going to go down to the lowest number. I'm going to do it for the function, not for the data. So the function, the lowest number is going to be 6.56 million. That's my lowest number. To my highest number. What's my highest number here? 8.99 million. Y-E. I'm going to go Y-E-R. I know I probably shouldn't, but that's a different story. There we go. See you in the next video.